All right, so theorem. If a function is differentiable at a given point, then it is continuous at that given point. Okay? But please note that the converse of that is not always true. Okay? If it is differentiable at a given point, then it is continuous. Okay? If it is not continuous, it cannot be differentiable.
What is differentiable?
Differentiable means that the derivative or the slope of the graph coming from one side is the same as the derivative or slope of the graph coming from the other. Just like the limit, it approaches the same value as a limit. The derivative should be the same as it approaches that point. All right? So, that brings us to the intermediate value theorem for derivatives. All right. These are funky, but, we'll do some work and hopefully it becomes more clear. If A and B are any 2 points on the interval for which f is differentiable, then f prime takes on every value between f prime A and f prime B. Sounds weird, doesn't it? Yeah. Good. I'm glad I'm not the only one. So, all right. Numerical derivative. I need to figure out what f prime of 10 is. Okay? How can we figure out what f prime of 10 is? Well, f prime means the derivative of this function, and then I need to put a 10 in there for x after I find the derivative, and figure out what it is. You think you know what it is? It might be 20. It might be 20. But how are we going to figure out what the derivative is? Sweet.
Oh my God.
Sweet. By the way, interesting. That's my TA. I did that. I didn't understand.
Nice.
All right. So we use a difference quotient. It's a difference quotient. So we have an A there instead of an X. Was that a mistake? No, it was not a mistake. Wait for it. Look at that. What's different about that symmetric difference quotient? There's an A on the other side too. So my TA was correct to have that in there. It wasn't he or she. It was just me. No. All right? But what does that mean? Okay. Let's say we have an A value, okay, of 10. Let's say A equals 10. What I'm going to do here, is I'm going to pick some number H, and I'm going to add it to 10 and subtract it from 10. Okay, and I'm going to put it all over to H. Why would I do that? If I have a graph here, and everything's always better with visuals, and let's say here is where X is equal to 10. We have some graph, I don't know, right? And I want to figure out at 10, well, where does the word symmetric come in? Let's pick an H value. Let's say H equals 1. I go 1 this way, and I go 1 this way. And then I try to figure out that average. See, and the closer and closer I get with those points, the more accurate my answer is going to be. Does that make sense? Just like when I get the slope of two things, those 2 points, as they get closer and closer to that 1 point, to where they're so close there's not even a difference, that's the actual slope. Same thing applies here. Okay? So, let's start with H is 1. So we're going to have f of 10 plus 1 minus f of 10 minus 1 all over 2 times whatever my H is, 1.
So you just do any number 3.
As long as it's, so yeah, and that will make it symmetrical. Let's say it was going 2 away. I go 2 more than 10 and 2 less than 10. But the whole point is to get smaller and smaller numbers And it'll get closer and closer and closer to what actually f prime of 10 is. Does that make sense? Yes, question. Well, yeah, but in calculus, 1 seems like an eternity. Eventually we'll get to like 0.5, 0.01, you know what I mean? We'll be closer. And since you guys have calculators, we're going to do this in the calculator. So basically, I want f of 11 minus f of 9 all over 2. Well, our function just tells us to square whatever is in the parentheses, right? Because it's x squared. So that is 121 minus 81 all over 2. What is 121 minus 81?
40.
40. What's 40 divided by 2?
20.
And isn't that what we had some random student? I don't know who it was that said that over here. That said it's 20?
I did.
That would be 40 over 2, which is 20. Look at that.
I think that's that.
Because you know,
I remember these last year.
yes. Yes, he does. So, there we go. It's really not that difficult. I could pick any value. Should we pick a smaller value? Should we pick 0.03?
No.
5 is not smaller than 1. Stop it.
0.5.
You want to do 0.05?
Yeah.
Okay. Well, we had 0.05.
Just do 0.5.
Do it like this.
Okay, 0.5. Well, we can do it again if you'd like. I'm just saying f of 10 plus 0.05 minus f of 10 minus 0.05 all over 2 times 0.05, right? Because these are my h's. So, we really got to take 10.05 and square it. And 9.95 and square it, right? Because that's what these two values are. You get the function of 10.05 minus the function with 9.95 all over, that's 0.10, right? When I double that. What is 10.05 squared? Minus, what is 9.95 squared? What is it? I'm sorry. 0.0025 divided by 0.10. Put that in your calculator and see what we get. 20? It should be. It should be. It should be the same. Right. So
if you like
you can. You can. It's just cool stuff. Yes, question in the back.
I didn't think that in
What do you think? 10.05 and square it? Take 110, or excuse me, 10.05 and square it. Ooh, did someone make a boo-boo? 10.05 squared. Oh my lord. That is 101.0025. Question. How do we know that's wrong? How can we figure out that's wrong? Yeah, this should be some number. When I divide by this, it should be 20. This doesn't give you that gives you some crazy decimal. If I take 0.25 and subtract 0.0025, you get 0.2475 at the end.
Yeah.
That won't be 20. That won't be 20. That's why I want a lot of you. That's why I want a lot of you guys do this in a calculator. Because I can do some of this stuff in my head, some of it I can't. Don't be shocked that I can't do that in my head. I'm sorry, I couldn't swear. All right? All right, so we have f of x equals x squared. And we figured out what? That if we found the derivative, we put a 10 in for x, it was 20. Right? So, if I put a 10 in for x, and the derivative was 20, what do you think the derivative was in terms of x? 2x. 2 times x, right? Because 2 times 10 is 20. So the derivative was probably 2x, which means if I throw a 10 in for x, that's where I get my 20 from. Does everybody see that? If I do the difference quotient, I can prove that to you. And you don't have to write this down just for the sake of time. Let's put this in the difference quotient to see if we're correct, right? It is f of x plus h minus f of x all over h as the limit of h approaches 0. That should come out to be 2x, right? So I've got x squared plus 2xh plus h squared.
You want to write that?
No, minus x squared. Just follow along, all over h. And if you did this right, this term should cancel with this term, and there should be h and everything that's left. H, and this one's a 1. So what I'm left with is 2x plus h, and don't forget it's the limit as h approaches 0. If this is 0, and indeed my derivative is 2x, that is the derivative of x squared. So you were right to make your assumption that, oh, okay, well, if I throw in an x, 10 in for x, and it's 20, well, I'm probably doubling whatever x is. That's correct. Now let's let the calculator do all the work for us. Let's use a calculator to find out what f prime of 10 is. Hit the math button, and option H give you an ender. Ender. So I'll get this up here, large screen it, and we'll hit what math? And option 8. Yeah, right down there. Enter. When I hit enter, that's what you get. It's dy, or well, it's d over dx. You always use an x variable. And in the parentheses, we put our original function. I want to find out what the derivative is. That's what d over dx stands for. The derivative is the derivative of what? Of x squared. And what do I want the value of x to be? 10. When you hit enter, what do you get? You absolutely get that. So
when this is estimate at
if they want to know f prime of 10, that's where this goes. That's what you want to put into the function after you find its derivative. This here is telling you find the derivative of this function here. And when I do that, throw in this value into x after. Alright? That's what I have these things right here for you. This will always be your x. This is your function. Whatever f of x is goes in here. That's x squared. And this is what you want your x to plug into the derivative. Okay? Alright? So, now your calculator does it for you. But do you want to know the cool thing? I'm going to tell you something cool. Your calculator does not use the difference quotient. Your calculator does not use f of x plus h minus f of x all over h, the limit as h approaches 0. I know you're distraught. Okay? Your calculator actually uses the symmetric difference quotient. The symmetric difference quotient. Slightly. Now, sometimes the calculator gives a wrong answer. Okay? If you use ender and your answer is 0, sometimes you got to take a look at it because there may be a corner or a cusp, and the derivative might not actually exist there. All right?
So it doesn't work on the corners or
Well, if it's a corner, a V, or a cusp where it's that kind of point, those are instances where there is no derivative. So that's why it won't work. It might just say 0 instead of error. Okay? Because it uses this. It's because it uses the symmetric difference quotient, not just the regular difference quotient.
So what if they have